Assalamu alaikum everyone, I'm Dr. Junaid Ahmed and we'll continue our course EEE 251 Probability Methods in Engineering at ComStats University Islamabad. Today's topic is expected value and movements of discrete random variable. This figure is from your book. Here it shows 150 repetitions of a random experiment to generate two random variables x and y. Okay, how we got them, let me start with a simpler example. For example, if we roll a dice, now dice has 6 outputs, 1, 2, 3, 4, and 5 and 6. And if we want to draw their outcomes, for example, I rolled it once, I got a 3, and then I rolled a second time, and I got a 5, and a third time I got a 1, and a fourth time I got a 2 and a 6 and 4, etc. So I'll have something like that. So my random variable is the number of dots facing up, and these are all the outcomes that it has in these 5 trials. So let's come back to this example. Here we have a random experiment using which we generated two random variables x and y. We performed the experiment 150 times, and all these are the outcomes of random variable x, random variable y, and all these outcomes are for the random variable x. I want you to have a look at these outcomes and spot two major differences between these two random variables. Okay, the first one is easy. X is kind of centered around this line, which is 5. Okay, and y is centered around this line, which is on 0. So what we can say is the mean value of x is 5 and the mean value of y is 0. This mean value is called the expected value of x. It is the value around which the random variable is spread, basically. So in our example that we did earlier, roll of a dice, what do you think would be the mean value? Will it be 3 or will it be 4? Because these are the two possible values, I should say. They are in the middle. But it cannot be 3 because there are two possible values less than 3 and 3 possible values more than 3. And it cannot be 4 as well because there are two possible values more than 4 while 3 possible values less than 3. So the answer would be, it should be somewhere in between 3 and 4, right? So this would be 3.5, which is correct. The expected value of this random variable is 3.5 because the random variable is spread around 3.5 evenly. Okay, so it evenly takes values below 3.5 as well as above 3.5. This can be seen from its PMF as well. So this is the PMF of this random variable. The possible values are 1 to 6. All values are equally likely, so all of them have the probability 1 by 6, right? And kind of the mean value, you can see, is in the middle. Now this mean value does not have to be one of the possible outcomes. For example, 3.5 is not a possible outcome, but it is still the mean value. This is is something that you should remember. And secondly, it does not have to be right in the middle of all the possible values. It can be thought of something like a center of gravity. So think of all these bars as weights. The higher the bar, the more the weight. So if you want to balance this bar somehow, where will it balance? It will balance exactly at this point, right? Let's say the dice, I take a different dice and it is not a fair dice. So there's a higher chance of getting a 6 and a 5. Okay, so this possible is outcome is more likely to, let's say 2 by 6 probability, with 2 by 6 probability that it gets 5 and 6, and then correspondingly less likely that it gets 1, 2, 3 and 4. So let's say this is 1 by 12 and all of these values are 1 by 12. So now will this change the expected value? Well, it will. Even though 3.5 is still the mid value in from going from 1 to 6, the mid value is still 3.5, but the center of gravity is not 3.5 anymore. So we have more weight on this side and lesser weight on this side. So the center of gravity will definitely shift towards the right. And the same thing will happen to the expected value. The expected value will be more than 3.5. It will not be 3.5 anymore. So the expected value is somehow, it can be thought of as a center of gravity of the probability mass function. And you can think of it as the mean value, the center value around which the random variable is spread. In the next lecture, in the next slide, in the next video, we'll see how we can mathematically calculate it. Now, the second difference that you can spot from looking at these outcomes is the spread of this random variable around the mean. So for example, if mean is 5, the random variable can take values from 3 to 7, so 2 points below and 2 points above, right? So the spread is bigger, while the spread of y is not that big. It only go 1 down and 1 high. So it can go from -1 to 1, which is 1 less than the center value and 1 more than the center value. So the spread is smaller. Okay, this property of how the random variable is spread around the mean is captured by the moments of the random variable. So the first moment is actually is called the mean, and the second moment is the minus the first, is called the variance. So the moments basically capture how the random variable is spread around the mean, while the expected value captures the mean of the random variable. In the next videos, we'll see how we can mathematically calculate these values. Thank you very much.